Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. So already we have completed 3 videos in the topic of limits. We have seen whether the limit exists or not using LHL and RHL, and then we have discussed many problems from that particular concept. And in today's video, let us see what are the rules we are going to follow to find the limits. Okay, and then we will find the limits using the very basic method called substitution method. Okay, and then we will have some examples. So these are the topics that we are going to look into in today's video. First, let us look what are the rules to find the limits. So let us see the rules that we are going to follow to find the limits. First, the first rule says that when two functions f of x and g of x are under addition. Okay, now for this, if you are trying to find the limit x approaches a, so then we can say that it says that under addition you can separate the limits. So which means it is equal to limit x approaches a f of x plus limit x approaches a g of x. So that is the first rule. And what is the second rule, dear students? Not only under addition, even under subtraction also. So that means what? If two functions are under subtraction, then also we can separate the limits. So if it is limit x approaches a f of x minus g of x, then we can separate the limits for both the functions. For f of x we can give limit, and then for g of x also we can give the limit. Okay, now for example, if you want an example, limit x approaches pi by 4 x square plus sin x. If this is the function, we can separate the limits here. You can give limit x approaches pi by 4 for the first function and limit x approaches pi by 4 for the second function. And then we can substitute the values and then we can find the answer. Okay, now that is the first formula. Under addition or subtraction, we can separate the limits. And similarly, if you think whether it applies for the product of f of x and g of x also, then you are true. So what is the second formula? The second rule, limit x approaches a f of x into g of x. Two functions are under multiplication. Can I separate the limits for each function? Means yes, of course. It is equal to limit x approaches a f of x into limit x approaches a g of x. So we can separate the limits for two functions which are under multiplication. Same way, dear students, limit x approaches a f of x by g of x is there. Can I separate the limits for the numerator function and denominator function? Means yes, of course. You can give limit to the numerator and limit to the denominator. Okay, if you want an example for the third one, let us see an example. Limit x approaches pi by 4 x square, not pi by 4, let us take 2 x square plus 4 divided by x square minus 3. So then we can separate the limits to the numerator. Limit x approaches to x square plus 4 divided by limit x approaches to x square minus 3. Then you can substitute the values and then you can calculate the limits. Okay, so this is the third formula. And but one important thing while calculating or while using the third formula is that, observe one thing, who is in the denominator here? In the answer in denominator we have limit x approaches a g of x. Now this should not be equal to 0. That you have to remember. Okay, now so only then we can say that limit x approaches a f of x by g of x. What do you call it? If this is not equal to 0, then happily you can separate the limits for the numerator and denominator. So that is third formula. Next, fourth formula. Dear students, there is a function f of x which is multiplied with some constant, some real number k, where k is any real number. It is k into f of x. Then k does not need the limit. It is a constant now. So k is independent of x value. It does not need the limit. We can write it as k into limit x approaches a f of x. So limit is given only for the function f of x. Okay, now k does not need any limit. For example, limit x approaches 0 or let me take limit x approaches pi by 3. Limit x approaches pi by 3, 5 into sin x. If that is the case, 5 does not need the limit, so we will write 5 into limit x approaches pi by 3 sin x. So limit is given only for the function sin x but not 5. Okay now, so this is the fourth rule. Fifth rule, if it is limit x approaches a, f of x power g of x. Observe the base is a function of x and the power is also function of x. Then we can separate the limits to both base and also power, which is equal to limit x approaches a, f of x whole power limit x approaches a, g of x. We can separate the limits for both the functions. For example, limit x approaches 1. Log x whole power sin x. If that is the case, then you can give limits to the base and at the same time power. Okay now, so we can write it as what? Limit x approaches 1 log x whole power limit x approaches 1 sin x. And then you can calculate its further value. Okay, so next the sixth rule. So what is the sixth rule? Sixth rule, limit x approaches a, f of g of x. It is a composite function. For the function f, the input is not x but it is g of x. Then how do we find this limit? Simple. You write it as f of, give the limit only for g of x. Limit x approaches a, g of x. Assume that this number is m. Let us assume that limit exists and it is m. Okay now. So you have to understand one thing. See, I can I can find the answer if and only if the function f is continuous at the number m, at the input m. So we can calculate this value if and only if the function f is continuous at m. So when a problem is taken, you will understand it. Okay, fine. Let us go for the seventh rule. Always understand one thing, dear students. Limit x approaches any number f of x. If the answer tends to plus infinity or minus infinity. What if the function approaches plus infinity or minus infinity when x approaches a? Then remember one thing, students. When x approaches a, then the reciprocal of this function approaches 0. Okay now. So when the function approaches plus infinity or minus infinity, then at same x value, its reciprocal will approach what number? 0. Okay now. So these are the basic rules that we will use always in all the problems while finding the limits. Keep this in mind. Now let us see an example based on this basic concept. Here is our first example. So if limit x approaches a, f of x plus g of x is 3 and limit x approaches a, f of x minus g of x is 2, they are asking us to find limit x approaches a, f of x by g of x, if it exists. If the limit exists, they told us to find this. So let us use our rules of finding the limits and let us simplify this question. Very simple solution only. According to the first rule that you have learned, I can take limit inside for both the functions, correct or not? So I can write this as limit x approaches a, f of x plus limit x approaches a, g of x. So which is equal to 3. Similarly here also under subtraction I can separate the limits. I can call it as what? Limit x approaches a, f of x minus limit x approaches a, g of x. So which is equal to 2. So these are two equations. Let me add them so that this and this will get cancelled. And limit x approaches a, f of x plus same thing. It is what? 2 times limit x approaches a, f of x. And the answer is what here, since you are adding it is 5. Then we can find what is limit x approaches a, f of x. How much do you get, dear students? So limit x approaches a, f of x will be equal to 5 by 2. A simple solution, correct or not? I only got f of x value 5 by 2, which means what? The limiting value of f of x. I should also find the limiting value of g of x. So let me substitute in this first equation. Substitute the value of limit x approaches a, f of x, and its value is what? 3 by 2. Its value is, sorry, not 3 by 2, its value is 5 by 2. This one's value is 5 by 2 and you are supposed to find limit x approaches a, g of x, correct? Which is equal to 3 according to first equation. So take 5 by 2 right side and automatically you will get limit x approaches a g of x, which is equal to 3 minus 5 by 2, which is 1 by 2. So I got the limiting value of f of x and I also got limiting value of g of x. They are asking us to find limiting value of f of x by g of x. So how do we find it? Simple. As I told you, so according to the third rule of limits, I can separate the limit to both numerator and denominator. So when I separate the limit to both numerator and denominator, we get limit x approaches a f of x divided by limit x approaches a g of x. So numerator's value is 5 by 2 whole divided by denominator's value is 1 by 2. So by 2 1 by 2 will get cancelled. The answer is how much, dear students? 5. The answer is 5. So they told us to find what? Limit x approaches a f of x by g of x. They told us to find this if it exists, and the answer is how much? 5. Okay now. Similarly, why can't you try this? For the same question, can you try to find the value of limit x approaches a f of x into g of x? You can try this question. Okay, we'll go with the next concept, which is what? The method to find limits using substitution method. Before continuing with next topic, it's very important to remember this point, an important point to remember. Until the previous video, whenever they are asking us to find limit x approaches a f of x, what we did, dear students? We found LHL, the left hand limit, we found RHL, the right hand limit, and if LHL is equal to RHL, assume both are equal to some number L, then I said that the limiting value of this function is L. Correct or not? Until the previous example, we have found LHL and RHL. But actually, to say, in most of the questions that we are going to discuss, in most of the questions, it is not necessary to find LHL and RHL separately. Not needed. Okay, now, if you know that the given function is, if you know that the given function f of x, the graph of y is equal to f of x, is continuous at x is equal to a. If you know that it is continuous at x is equal to a, we don't have to find LHL and RHL separately. Directly we can find the limit. What I am trying to say is, I'll give you an example. See here, the coordinate axis. Let us consider a number called x is equal to 2. Input 2. Okay, and let us draw some random graph of y is equal to f of x. Assume that this is the graph of y is equal to f of x. See, exactly at x is equal to 2, if you observe, the graph is continuous only, na? So for continuous functions, what is the speciality means? When x approaches 2 from the left side, the graph is approaching this number. What is this number? Let this number is 5. Okay, now when your input is approaching 2 from the left side, the graph is approaching 5 from the left side. And when your input is approaching 2 from the right side, then also the graph is approaching same number from the right side, 5. So the speciality of continuous functions is that LHL will be certainly equal to RHL. For those kind of functions, LHL will be equal to RHL. You don't have to find LHL and RHL separately. Directly you can find RHL, right hand limit. Okay, now, so no need to find LHL and RHL separately. We will directly find the limit of the function. But if you have a doubt whether the given function is continuous at x is equal to that particular number or not, if you have a doubt, then we will check LHL, we will check with RHL, and then we will check whether the limit of the function exists or not. Okay, now particularly, sir, for what kind of functions we can find the limits directly, and for what kind of functions we have to find LHL and RHL means, I'll give you clarity about it now. So the functions like trigonometric functions. What functions? Trigonometric functions. FNS means trigonometric functions. Next, inverse trigonometric functions. If you find trigonometric functions or inverse trigonometric functions, logarithmic function. If you find logarithmic function or exponential function, polynomial function, any polynomial function or rational function, if you find these kind of functions, if you are trying to find limits of these kind of functions, you don't have to find LHL and RHL separately. Directly you can find the limit, because these functions, if you look at the graph of these functions, they are continuous in their domain. Please underline this word. These functions are continuous in their domain. Okay na? So these functions are continuous in their domain. Sir, how do we exactly say whether they are continuous in this domain or not? Means in the upcoming chapter called continuity, you will get more idea. But it's better if you know how to draw the graphs of these functions. You should know these are our basics. If you want to learn the topic of calculus, if you want to really do well in calculus, you should know how to draw the graphs of the functions. Draw the graphs of trigonometric functions, inverse trigonometric functions, logarithmic functions, exponential functions, polynomial functions or rational functions. Look at their graphs. They are continuous in their domain. Once again, underline that word, in their domain. Because one student told, sir, you said that trigonometric functions are continuous in their domains, but what if you look at the graph of tan x? The graph of tan x is like this. Exactly at pi by 2 there is a break, and again the graph goes like this. He told me that the graph of tan x is not continuous now. But understand one thing, pi by 2 is not in the domain of tan x. Pi by 2 is not in the domain of tan x. Okay na? If pi by 2 is in the domain of tan x, I would have told it is not continuous. But pi by 2 is not in the domain of tan x. So which means that tan x is continuous function. Okay na? Anyhow, we'll have more clarity about continuities in upcoming chapters. You understand one thing. If you are finding limits of these functions, then directly we can find the limits instead of using LHL and RHL. You will get more clarity when we are solving the problems. I'll also tell you, if needed, why we are not supposed to find it, why there is no need of finding LHL and RHL. I'll give a clarity about it while solving the problems. Now the question is, sir, then for what kind of functions do we need to find LHL and RHL? I'll discuss it now. For greatest integer functions, particularly when you are trying to find step of f of x, limit x approaches a, step of f of x, greatest integer function. Okay na? And when x is approaching a, if f of x is approaching an integer, or let me give more clarity, if x approaches a, when x is equal to a, let us say like this, when x is equal to a, if f of x is an integer, okay na, at that particular moment you have to find LHL and RHL, okay na, or let it be, if you find step function, find LHL and RHL. Is it clear? Okay na, particularly when we must find LHL and RHL means when x approaches a, if f of x is approaching an integer, then we must find LHL and RHL. But whatever it is, if you find step function, find left hand limit and right hand limit and check whether limit exists or not. And at the same time, even when you are trying to find fractional part of f of x, limit x approaches a, fractional part of f of x. For this function also, it's better to find left hand limit and right hand limit. Next, for what else we will find the left hand limit and right hand limit means for signum functions. Already we have discussed what is a signum function, correct or not? Okay, for signum functions, we will, if you are trying to find limit x approaches a, any signum function, then you can take LHL and RHL, and then you can check whether the limit exists or not. Signum functions, if you want an example, already we discussed one example. What is it? Limit x approaches 4, mod x minus 4 divided by x minus 4, mod when limit x approaches 6, mod x minus 6 by x minus 6. Okay, now limit x approaches 0, mod x by x. These are signum functions. Okay, now for these kind of functions also we have to find left hand limit and right hand limit. Okay, and one more important function is there where it's very important to check LHL and RHL. What is it? Dear students, let us assume that x is equal to a number a. X is equal to a is a 0 of a polynomial called a polynomial or any function f of x. Let us assume that x is equal to a is a 0 of the function f of x. Okay now, and at the same time you are trying to find limit x approaches a 1 by f of x. x approaches a f of x. Then what happens, dear students? When x is approaching a, f of x is approaching 0, then you are getting 1 by 0, which means your answer looks like plus infinity. Correct or not? In these kind of situations, you find LHL and RHL. I'll give you a better example. Look at this example. Limit x approaches to 1 by x square minus 5x plus 6. So what students will do generally, they will try to substitute x as 2. Okay, now they will get 1 by 0. Correct or not, dear student? They are getting 1 by 0. We know that limit can be infinity, and they will say that the answer is infinity. They will say that limit of the function is infinity. But the problem is that x is equal to 2 is actually a factor, is actually a 0 of this polynomial, x square minus 5x plus 6. Correct or not? In place of x, if you substitute 2, the center value will be 0. Then you cannot directly find the limit. You are supposed to find the left hand limit and right hand limit. Let us see once in this kind of function what happens if I find left hand limit and right hand limit. And you know that so this function is what? Limit x approaches to 1 divided by x minus 2 into x minus 3. I told you to, if you want to evaluate this, find LHL and RHL separately. If you take LHL, dear students, LHL is what? Limit x approaches 2 minus 1 by x minus 2 into x minus 3. X approaches 2 minus means what? It means x is equal to 2 minus h, where h approaches 0. So you can substitute x as 2 minus h in this function. 1 divided by x means 2 minus h. So 2 minus h minus 2 into, again x is what? 2 minus h minus 3, where limit h approaches 0. And this will get cancelled. And what you get? 1 divided by h into, you can give minus here. If you give minus here, then what happens? Minus h will become plus h, and minus 1 will become plus 1. Limit h approaches 0. Please observe one thing, dear students. When h approaches 0, h is positive number only, na? So positive, h is not 0. H is only approaching 0. But it is 0.0000 and so on. It is positive value. And this is also positive value. H plus 1 will be positive value. Positive plus into positive. Positive into positive is positive, and h is approaching 0. So 1 divided by 0.00000 and so on. What is the answer? When you are finding the left hand limit, we got the answer as what? Plus infinity. Please observe, LHL if I calculate, I got what? Plus infinity. Left hand limit I calculated and I got plus infinity. Let us see what if I calculate right hand limit. For right hand limit, we will take what? While calculating right hand limit, x approaches 2 plus. X approaches 2 plus means x is equal to 2 plus h. Substitute x as what? 2 plus h here and also here. So automatically plus 2 and minus 2 cancels, you will get h only, and here you will get h minus 1. Correct or not? You will get h minus 1. And you know that h is approaching 0. So it is 0.00000 and so on. This is 0.0000 and so on. Approximately 10 power minus 20 or whatever. Positive value. And what about h minus 1? Is negative value, correct or not? 0.0000 and so on minus 1 will be a negative number. Positive into negative number, negative. So it will be minus. And of course, when you are multiplying with an infinitely smaller number, 0.000 and so on, the denominator will be approaching 0. So 1 divided by 0 will be again infinity with minus sign. So dear students, the right hand limit is minus infinity. In this question, right hand limit is minus infinity. Left hand limit is not equal to right hand limit, therefore the limit of this function does not exist. See, when I asked you to solve it first, you might have got the answer as infinity, correct or not? You will say, sir, I directly substituted x is equal to 2, I got 1 by 0. 1 by 0 means infinity only, na? So limit of this function exists, it is equal to infinity, you can mark it. But why we got wrong answer? Because x is equal to 2 is a factor of denominator, or particularly x is equal to 2 is a factor of this one, this particular function. Because of that reason only, I told you to find LHL and RHL separately. Remember this once again. When we will find LHL and RHL separately, if x is equal to a is a 0 of this particular polynomial f of x, and you found f of x in the denominator. And one more important thing is f of x doesn't get cancelled with the numerator. Sometimes what happens means you'll get an example like this. Limit x approaches a, f of x divided by f of x into g of x. Of course, yes, x is equal to a is a 0 of f of x. Okay, now, but still f of x and f of x will get cancelled. Nah, it will not be there. Then you can find the limit directly. Okay, now f of x should be there in the denominator and it should not get cancelled with the numerator. Then it's very important to find LHL and RHL. I hope you understood this. For these kind of functions, we will find LHL and RHL. Okay, now we will not calculate the limits directly. Okay, fine. Now let us see one of the basic methods used to calculate the limits. And this method is called substitution method. It is not just a basic method. It is very important method, because when substitution method will not work, that method itself will tell you which other method you have to choose. Okay, now so we will discuss about the other methods in next video. In this video, let us discuss about substitution method. Very easy method. Let us see what is this substitution method of finding limits. Dear students, let us assume that there is a function like this. We are supposed to find the limiting value of this function f of x at x is equal to c. And dear students, first of all, find the value of the function. This is limiting value of the function and this is value of the function. Correct or not? First of all, substitute x as c. Okay, na? And it is what? F of c only, na? If this f of c is a real number, then the answer is f of c. That's it. Directly substitute x as c. And if your answer is a real number, then that is the answer. But wait. This is true only when f of x is continuous at x is equal to c. Are you understanding this? Blindly, what you will do? You will substitute x as c here. You will get f of c. It is a real number. It is a finite number. And you will say that is the answer. But please wait. When can I use substitution method? If you know that f of x is continuous at c. If you think about its graph, you will understand. Or slowly by practice, you will get more clarity. Okay, now fine. And similarly, if you find a function like this, limit x approaches c, f of x by g of x. Do one thing. Substitute x as c and find the value of f of c by g of c. If this is a real number, if it is finite and real number, then yes, the answer is what? The answer is f of c by g of c. Okay, now first let us see the example where the substitution method actually works. Okay, let us see an example. A basic example, dear students. Limit x approaches to x square minus 1. X square minus 1 is a polynomial function. Just now we discussed that it is continuous. I gave you a note na. Polynomial functions are always continuous. We know that x square minus 1 is a continuous function. So happily you can substitute x as 2. Substitute x as 2. 2 square minus 1. The answer is 3. 3 is a real number only na. So the answer is 3. That's it. Substitution method works when you know that this function is continuous at x is equal to 2. Okay, na? And at the same time the answer should be a real number. Okay, na? Another example, if you want, limit x approaches 4, x square minus 3 divided by x plus 2. This is a rational function. We know that rational functions are continuous in their domain. Do you know how to find the domain of a rational function? The domain of this rational function is any real number except the zeros of the denominator. What is the zeros of the denominator? X is equal to minus 2. Correct or not? So this is the domain of this particular function. Except at minus 2, the function is continuous for all the remaining inputs. And you are trying to find what? Limit at x is equal to 4 only, na? At x is equal to 4, the function is continuous. Don't worry. Every time we will not be checking whether the function is continuous or not. You will understand by practice. Substitute x is equal to 4. 4 square minus 3 divided by 4 plus 2. 16 minus 3 is 13 divided by 4 plus 2 is 6. The answer is a finite number, 13 by 6. Therefore, limiting value of this function is how much? 13 by 6. So once again, dear students, x must be in the domain of the function f of x. Okay, x is equal to c should be in the domain of f of x. And next what we will do is, we will substitute x as c. And the answer is f of c. Okay, the answer is f of c. So we will take the answer as f of c if f of c is what number? Any real number. Okay now, so if the answer is a finite and any real number, we will take the answer, just like these two examples. I'll give more examples, but the question is, when does the substitution method is a failure means? Look at this example. Limit x approaches 3 step x. Our first example when we are using LHL and RHL. I told you already, if you find step function, immediately go for LHL and RHL. Correct or not? Anyhow, you will go for LHL and RHL only. But once again, check whether substitution method works or not. What I told, in place of x, if you substitute 3, you will get what? Step of 3. What is step of 3? Step of 3 is 3. The answer is a finite number. So does it mean that limiting value of the function is 3? Does it mean that limiting value of this function is 3? Can I say that by substitution method we got the answer as 3, therefore the answer is 3? No. Here the substitution method is a failure. You know already how to find this answer using LHL and RHL. In left hand limit you will get the answer as 2, and in right hand limit you will get the answer as 3. Left hand limit is not equal to right hand limit. That means what? The original answer for this question is what? The limit does not exist. The original answer for this question is what? Limit does not exist. But some students, what they will do, they will use substitution method. They will substitute x value as 3. They will say step 3, and step 3 is 3 only, na? They will say the answer is 3. But are you understanding, dear students, when to use substitution method and when not to use substitution method? Here substitution method cannot be used because step x is not continuous at x is equal to 3. If you remember the graph of step functions are not continuous at x is equal to any integer. So at x is equal to 3, step function is not continuous. You must go for LHL and RHL. You cannot use the substitution method directly. So remember once again, I can use the substitution method particularly here if you know that f of x is continuous at x is equal to 3. Or think about it. By practice, it will be a habit. And at the same time, dear students, when I substitute x as c, I'll get f of c as answer. This must be a finite real number. Okay. Let us see some examples to get habituated to substitution method. Okay, dear students, let us evaluate these limits. First of all, we will check whether substitution method will work or not. Rational functions, they are continuous in their domain. Okay, now the domain is what? All real numbers except plus 2 and minus 2. And you are not approaching plus 2 and minus 2. So happy. You are approaching 3 only, na? 3 is in the domain of this rational function. Substitute x as 3 directly. 3 plus 1 by 3 square minus 4. So the answer is 4 divided by 5. And it is a finite number, finite real number. So this is the correct answer. The answer is what? 4 by 5. Next, here also you can substitute directly. So 4 plus cos pi by 2. X value is pi by 2, na? Cos pi by 2 is 0 divided by 2 minus sin pi by 2 is 1. So it is equal to 4 by 1. The answer is 4 by 1, which is nothing but 4. The answer is a finite number, so it is correct. And at the same time, wait. The denominator cannot be 0 for any values of x. Actually, denominator is 0 if sin x is 2. But sin x cannot be equal to 2. Correct or not? So you don't have to worry about it. Next, here also you substitute x as 0. So 4 plus 0 divided by 3 minus 0 whole power. Sin 0 is 0 minus sin 0 is 0. Only 3 will be there in the power. So 4 by 3 whole cube means 4 cube. 64 divided by 3 cube. 27. So I got a finite answer, right? So that is correct answer. Okay, now whenever we substitute this number in the function, if you are getting a finite answer, finite real number, then that is the correct answer. But understand one thing, substitution method works only when this function is continuous at x is equal to 3. Okay, now slowly you will habituate to know whether the given functions are continuous at x is equal to that number or not. Okay, now we will go with next question. Important model question, please observe. Limit x approaches infinity, cos x by sin x. A simple question. The denominator is approaching what number? Infinity. I should not write infinity actually. The denominator is infinitely larger number. X is approaching infinity only, na? The denominator is infinitely larger number. Okay. And what about the numerator? Some students will say, sir, cos of infinity is not defined. Some students will say that. You cannot say exact answer. Yes, I will accept. I will say yes to your answer. Okay, na? Cos of infinity, we don't know what is the value, but cos of any real number is some number between -1 and +1. Correct or not? I don't know what is that value, but cos x, when x is approaching infinity, cos x is some finite number between -1 and 1. That number which is between -1 and 1 is a finite value. Dear students, the numerator is a finite value and denominator is infinitely larger value. So finite number divided by infinite number will be how much? 0. So when x approaches infinity, cos x is some number between -1 and +1. It is a finite value and the denominator is a infinite value. Finite value by infinite value is how much? 0. Correct or not? Similarly, can you try this question? I think you understood what I am going to write on the board. Yes, limit x approaches infinity, sin x divided by x. I think you can try this question. Okay, now, so we'll go with next question. Important model question. Let us see what is the question. Look at this question. It's very important to understand the question. Don't simply run behind solving a question. First of all, spend some time on the question. Try to understand the question. If you do not understand the question, we cannot do anything else, right? What they told in the question? They told that this represents a sequence of real numbers. What is the meaning of this first of all? It means sequence of numbers. What are the sequence of numbers? B1, B2, B3 and so on Bn. It is actually what? It is sequence of numbers. You know sequence and series already. This is sequence of numbers. Okay. Now in that sequence they have given the value of B1. So this one will be what? 2. The first number in the sequence is 2. Next, what they told is they have given a formula to find B suffix n plus 1. You can find B suffix n plus 1 using Bn. These kind of formulae are called recurring relations. Okay, now recursive relations or recurring relations, whatever it is. You can find, if you want to find B2, you should know what is B1. If you want to find B3, you should know what is B2. So a given term will be found using its previous term. Okay, now fine. So now whatever it is, they told that B suffix n plus 1 is given by this formula, and at the same time limit n approaches infinity, Bn is equal to B. We are supposed to find the value of this B1, which means we are supposed to find limit n approaches infinity Bn. Okay, now, okay dear students, understand one thing while solving the problem. When n is approaching infinity, limit n approaches infinity B suffix n plus 1 is same as limit n approaches infinity Bn. Because n is approaching infinity, na, then n plus 1 and n both will be same only, right? When n is approaching infinity. When n is approaching infinity, n plus 1 and n both are same only. So therefore both are equal to what? B. So remember this point. Okay, now let us take this particular recursive relation B suffix n plus 1. So B suffix n plus 1 is equal to 5 plus 4 into Bn divided by 4 plus 3 into Bn. And let me apply limit on both sides. What is it? Limit n approaches infinity, B suffix n plus 1 is equal to. And as I discussed in rules of the limits, this limit n approaches infinity is also applied right side. Okay, now fine. First let me write it. We just applied limit n approaches infinity on both sides. 5 plus 4 Bn by 4 plus 3 Bn. Now what I am saying is, according to rules of limits, limit can be given for the numerator and denominator. Okay, and particularly when you are giving limit to the numerator, 5 does not need limit. So 5 plus 4 into 4 will not take the limit. 4 into limit is given only for this. Limit n approaches infinity Bn whole divided by. Limit is for the numerator, limit is also for the denominator. Correct or not? And when we are giving limit for the denominator, this does not need the limit. 4 is a constant, na? So plus. So limit is given for this one, right? This term. 3 will not take the limit. 3 into limit n approaches infinity Bn. Does anyone get confused? Why 3 will not take the limit? I told you, na? Limit x approaches a, k into f of x is equal to k into, under multiplication or division, k will not take the limit. Limit is given only for what? X approaches a f of x. Because k is independent of x now. That is what I have applied here. You are giving limit for 3 into bn, but 3 does not need the limit, so it is outside. Limit is only for bn. Now dear students, I told you that limit n approaches infinity, b suffix n plus 1 is same as limit n approaches infinity bn. Both are same only because when n approaches infinity, n and n plus 1 both are same only. So therefore dear students, this value is b equal to, what is it? 5 plus 4b whole divided by 4 plus 3b. Now if you cross multiply this and if you simplify, you will get the value of b. Okay now, so let me solve it here. If I cross multiply 4 plus 3b, this is 4 plus 3b cross multiplied with b, so b into 4 plus 3b is equal to 5 plus 4b. Expand it, 4b plus 3b square is equal to 5 plus 4b, and take 4b right side and cancel it. You will get b square is equal to 5 by 3 and b is equal to, some students will write b square is 5 by 3 means b is only root 5 by 3. You have to understand, when b square is 5 by 3, b is plus or minus root 5 by 3. Okay na? And some students, what they will do, they will do this correctly and they will say that, sir, the value of b is root 5 by 3 comma minus root 5 by 3. They will say that both values are true. That's the problem. We are doing the entire solution correctly and exactly at the conclusion we are writing a wrong conclusion. Then you might ask, sir, what is wrong conclusion? Every step is correct only now. Means please observe one thing. b1 is 2. Positive number. If you want b2, you will take n value 1 only. Na? You will find b2. Okay na? N value 1 means what? 5 plus 4 into b1 divided by 4 plus 3 into b1. That means what? We will substitute b1 value as 2. So 5 plus 4 into 2 divided by 4 plus 3 into 2. Are you understanding what I am saying? If you want to find b2 using the formula, it is 5 plus 4 into b1 divided by 4 plus 3 into b1. b1 is positive. Substitute b1 as 2. Calculate. b2 will be positive. Why b2 is positive? Because b1 was positive. Same way find b3. b3 will be positive. Find b4. b4 will be positive. Like that every term will be positive. You only try to find b3 and b4, right? You will observe the pattern. Every term will be positive only. So in the sequence, every term is positive means even this is also positive. Even n approaches infinity, bn is also positive only. That means b value also should be positive only. Okay na? So, but b is positive in this particular sequence. Therefore, what is the only correct answer, dear students? The only correct answer is b is equal to root of 5 by 3. We will not take b is equal to minus root of 5 by 3. We will take only b is equal to root of 5 by 3. So b is equal to root of 5 by 3 is the only correct answer. Okay now I'll give a question which is similar to fifth question. You can try it yourself and you can let me know what is the answer in comment sections. Is it same model question? Another recursive relation. So a suffix n plus 1 is given by this particular formula. And they told that a suffix n is not equal to 0. Okay, now think about this. Conditions are always important. They told us to find the value of limit n approaches infinity an. Okay, same model, right? Just like the previous question. You can try it and you can let me know what is the answer in comment sections. Do comment it. So I hope you understood the concepts, dear students. So in case if you feel that the video was helpful, do like the video and share it with your friends. This is Sandeep Kumar and we will continue in next class with indeterminate forms. Okay, and of course before indeterminate forms we have sandwich theorem also. So we will see in next class, mostly it will be sandwich theorem and some extra concepts, some important concepts. We will discuss it in next video and after that we will go with indeterminate forms. Okay, thank you. See you all in next video. Take care.